Okay, now on to making the game. Now, so to make the game, because JavaScript doesn't have any interpreted language, we're going to use, I'm sorry, because JavaScript doesn't have any IDE, we're going to go ahead and use CodePen.io. It's basically like an online IDE for JavaScript. It lets you develop and then see the results of it by the side. When you first go to CodePen.io, it's going to look like this. You don't have to create an account, but I recommend doing it. If you create an account, you can save your code and access it from other computers. You can also save your code if you don't make an account, but if you do, then you'll be able to. Then you won't be able to access it from other computers, but you can still access it from your computer. When you create an account, don't. Here we go. Let's see if I say if you hit sign up, they really want you to buy it. You don't have to buy it. You can click that like the free plan button in the bottom, and that works just fine. So I'd recommend doing it. When you go there, you can see your pins by going to your profile. There'll be like some pins that you've created, but we're gonna create a new one. So you just hit new pin up there. By default, I think it makes the view this way, but I like this way because it's easier to program on, so you can change it just to make it better that way. Alright, well, without wasting too much time, let's get started. To start programming, we have to have an element to program into. By default, CodePens just gives us an empty iframe. So let's make something that we can write to. I'm gonna make a canvas element here. It's an HTML5 canvas element. Another thing, because of that, you should use a modern browser that supports JavaScript 3.0 and HTML5, so probably Chrome or Mozilla or something like that. I'm using Chrome. To access that element, I'm going to give it an ID, and I'm going to make it blatantly clear. I'm just going to call it canvas, okay? So nice clear idea. We're not going to use CSS. If you use CSS to style the canvas, that's fine, but if you use it to set the coordinate system, or the size of the canvas, the coordinates don't get updated to reflect the new size, so that's why I'm going to use JavaScript to do all that. Okay. Alright. So now I have a canvas. Let's go ahead and get it. So I make a variable called canvas, and I'm just going to equal that to document. Dot get element by ID, and we're going to use the canvas ID that we gave it. We're doing pure vanilla JavaScript stuff, no jQuery. Let's see. Okay, yeah, so we got a canvas. The next thing that we want to do is we want to make a context, a graphics context for that canvas. I shouldn't say, well, I guess, yeah, maybe create one. And that's just going to be equal to canvas.get context, and then that will be a 2D context that we want, not a 3D one. I think they support 3D or something like that. I'm not too sure. We also want to change the size of our canvas, like I said. So canvas.width is equal to, I like 750 pixels. And then we can also change the canvas.height to be equal to 750 pixels. That's pretty straightforward like that. If you're curious where I learned about the canvas element, in HTML5, that's pretty easy. You just go ahead and you Google canvas, right? And W3 schools, okay, canvas HTML5, right? And then you go to W3 schools. They're great for learning HTML stuff, and they'll tell you like how it works and how to even draw like simple lines and stuff. To learn about like the context, I normally like MDN. So if you go to MDN and then type in like context, you can see the Mozilla Development Network will give you kind of like a breakdown of how the context works and all the methods, or sorry, all the functions for a JavaScript 2D context and stuff like that. So that's where I learned this stuff. So okay, we got a context. Now let's go ahead and try to draw to it. So what we'll do is we'll say context.fill-style, and that's going to set the fill color for us. And I'm just going to make it, I don't know, blue, something that we can see. And then context dot, sorry, not draw to, fill rect. So we're going to fill a rectangle. Fill rect takes in an origin. We're going to start at 0, 0, and it also takes in a height and a width. We're going to do the canvas width. And then canvas dot height. Okay, so we're just going to draw to the whole rect, and I saved it, but there we go. You can see it draws to the rect. That's awesome. Now we're going to want to be doing this a lot because we're going to blank the screen in between updates. So we're going to, or in between each time we go around the loop. So we're going to write that to a function. So we're just going to have to type in, function, and I'm just going to call it loop because it will be, or no, I'll call it clear canvas. Okay, I'll even break this out a little bit further. And then instead of filling it to blue, because this is supposed to be a rocket ship, I'm thinking like in space stuff. A good space color, I think, is 2020. It's kind of like this gray color that's for the background. But 2020 is in hex, and RGB colors take in decimals, so we're gonna have to convert that over. I don't know how to do that in my head, so we'll just go to this decimal, go to hexadecimal. 20 in hex is 32 in decimal. So we want an RGB color, and it is 32, 32, 32, just like that. And now down here, maybe we'll test out our function. Canvas, does that work? Yes, and we get like that nice gray color. That's the same color I use for the background in Sublime Text. If you're curious, it's easy on the eyes, but it's not quite black. Alright, so that's what we're going to be doing. The next thing that we need is probably a game loop, right? So we want to update this 60 times a second. Now it's important to remember JavaScript's an interpreted language, it's not a compiled language. Because it's interpreted, the interpreter runs, or most of the time, and I'm pretty sure in Chrome, runs on one single thread. And that's the interpreter for the whole browser, right? So if we can't sleep the interpreter, because if we sleep the interpreter, everyone has to halt, right? If we can't sleep the thread it's on. So instead of sleeping it, what we do is we tell the interpreter, hey, we want to have an interval. So we say set interval, and basically what that will do is the interpreter goes around to all the code, the JavaScript code, and it time shares, gives it a portion of time to work on, and then interrupts it, and then goes ahead and goes to the next portion of code. And interval just says, okay, each time you go around checking all of people's codes, check to see if I'm in the interval, and if it's been enough time, call this function. Okay, and then we'll go around. So interval is not that accurate because it's, it has to go around and time share first, but it's fairly accurate for what we're doing. And if it will fire as soon as it can, and if it misses us once, that's okay. We'll just have a little bit of lag, and then it will fire us again next time around. That's okay for something like that. Set interval takes in two things. It takes the name of a function to call. So we're going to call, let's make a function. So we'll call a function, and we'll call it loop. So we want to go to the loop. So we want to call the loop function. And it also takes in the amount of milliseconds that it wants to call us on. Now I want to run this game at 60 frames a second. So if we invert that, we get seconds per frame, and interval takes in milliseconds. So we just multiply that by 1,000. So you take 1,000 and you divide it by 60, you get how many milliseconds that we want to fire this loop command for. And then the first thing that we're going to do in this loop is we're going to clear the canvas, because each time we go around the loop, we want to blank the canvas for us. So now we see we have a blank canvas, and we should be looping this at 60 frames a second. We'll test that out in just a bit. The next thing that we want to do is we want to create a rocket. Okay, and a rocket's going to use things like positions and accelerations and stuff like that, which are going to have X and Y components. And instead of trying to remember their X and a Y component for like their position and for the velocity and stuff like that, it'd be a lot more simpler and resourceful if we create a vector class, which is just something not like a resizable array vector, but like a math vector, which is just something with like dimensional components to it, right? So now we'll have an X component and a Y component because we're working 2-dimensional coordinates, right? So to do that, we just make a class. We say class and the name of it. I'm going to say vector. I use capital V to abide by convention. We're also going to create a constructor. Constructor gets called when a class gets created. In a JavaScript class, it's you can't assign variables out here. Like it can't do like x is equal to out here. That will give me a compile error. I also can't use, like, I know it's really close to an object, but you can't use comma or anything like that. Commas and colons. It really doesn't allow you to do anything. Everything that you want to set, like its own variables, needs to be set inside the constructor, so we'll do that there. and we set them by referring to the instance of whatever vector we're talking about. So the instance of it is, of course, this, and then we can go ahead and say what variable we want. So it needs an x component, and it also needs a y component, right? And I probably want to pass those through to the constructor, and we'll just say this dot x is equal to x, and this dot y is equal to y. We'll make a simple class like that. Now we can go ahead and make a rocket. So again, we want a rocket class. So I'll just say class rocket. Oops, rocket. Sorry. There we go. And it's again going to have a constructor because we're going to do a lot of things when we initialize a rocket. The first thing that we want to do is maybe give the rocket a color. So I'm going to give it a color. The color will be equal to cyan. That's a cool color, right? The next thing that we want to do is we're going to give it a position. So this dot position is equal to a new vector, and we're going to start it out at, let's start it in the center, okay? Well, let's just start at 0, 0 for now, because I'll show you how we center it. We also want to give it maybe a height and a width, so we'll say this dot width is equal to 10, and this dot height is equal to 20, so we'll make it like nice and skinny. It'll be long, and or it will be not that wide, but pretty tall, so that way it will look pretty good. Now, if we want to center this, well, yeah, okay, we'll get back to that. So we'll do that, and then another thing that we want to do is probably before we enter into, or before we define our loop, we should maybe define a rocket. So we'll say rocket is equal to a new rocket, right? Just like that, and it doesn't take any parameters, so we just give it empty parameters. And maybe we want to have a function inside the rocket instance that does something that animates the rocket. So I'll just call it animate. And animate's just going to do something. It's going to take the context, and it's going to set the fill style equal to this dot color, right? Because it's color. Oh yeah, another thing you can't do. Classes in JavaScript are just really like objects. So each time I can't refer to color and just have it refer to like its own color. It needs to be referenced to this each and every time. So that's kind of annoying, but that's just because how JavaScript works. So we set the fill style, and then we also going to want to say context.fill rect. So we're going to fill a rectangle. Our rocket will just be a rectangle at position. And I don't want to keep referencing this, so I'm going to make a variable position, which is just equal to this dot position, so that way I can just reference to position. And remember, this position is an instance of a vector, so these are both pointers. So if I update the variable position, I'll also be updating this position because they're both, it's a pointer to the same object. So we're going to say position dot x and position dot y, and we're going to do it for this dot width and this dot height, right? So we're just going to want to fill in the color of the rocket, and then each time we go around this loop, let's go ahead and just animate the rocket. So the first thing that we do is we clear the canvas. The next thing that we want to do is maybe do like rocket.animate. So we animate the rocket, and let's see what we get. Alright, we get nothing. That's annoying. What do we get? Position is not defined. Line number 34. Did I spell position wrong? I did spell position wrong. Position. There we go. So that should draw a nice cyan rectangle in the upper right. Now that's kind of off in the middle of nowhere. Maybe we want our rocket to be down here at the bottom like it's on a launch pad. So do that. We want to set it in the middle. So we want to say half of the width of the canvas. But remember that the origin of this rectangle, the way that we draw it, right? The origin's in the upper left-hand corner. So if we offset it, if we offset it by just the width of the canvas, it will kind of like start drawing it in the center, and then it will draw like the rectangle down this way, which you can understand that will look not in the center. So we also have to count for its own width. To do that, that's pretty simple. We just say our position starts at its canvas dot width, and then we subtract this dot width, right? We subtract our width, and then we half of that as a total, so that will center it in the screen. So it will offset it by half of our width, which will make us draw to the center. And then as far as height goes, in the canvas coordinate system, this is 0, 0, right? So this is the maximum height. So if we put our height to the canvas dot height, we'll be actually drawing under the screen. So we want to actually offset that by our height. So what we want to do is draw it to canvas dot height, and then we also want to subtract this dot height, right? So that we draw just to, I spelled height wrong, didn't I? H-E-I-G-H-T. There you go. That way we're drawing right to the bottom. You can see now it starts there at the bottom of the screen. Alright, so that's a good idea. The next thing that we're going to do is probably make the rocket move, right? So in order to to make it move, let's give it a velocity. So we'll say this dot velocity is equal to a new vector, and let's give it a velocity of 0, 0 to start out with, right? So at first it's just sitting on the ground, it's not doing anything. And then maybe we'll accelerate the object. Man, I can't spell today. Vector. There we go. We want to give it an acceleration. So we'll say this dot acceleration is equal to a new vector, and the acceleration, let's just make it accelerate. It's going to be in a distance measured in pixels, or sorry, it's going to be a change in pixels each time the animate goes around. Or sorry, each time the animate function gets called. If we set it to a positive value for the if we set this is the x component of acceleration, so we don't want to change which direction it's going this way, but we want to make it go up faster, right? If we set its y component to a positive number, because the coordinate system goes down, it will actually fly down the screen. So we want to fly up the screen, so we give it a negative value for its y component. So we'll say like negative, and we'll start out by just saying -1. That sounds like pretty straightforward. So we can go ahead and go down and animate, and then each time we go around, we can say this dot velocity dot add. So we can add the I didn't make add yet. So what we want to do is there's a perfect example. We want to add this dot gravity to this dot velocity, right? So we're just going to take the gravity and add it to the velocity. But I haven't created add yet, so we'll go ahead and make it real quick. Just inside the function, we'll say add. Add's going to take in another vector. Okay, and it's going to want to change, it's going to want to add our vector to the vector that we give it. So we're going to say this dot x plus equals vector dot x, and we'll also say this dot y plus equals vector dot y. Okay, that way we just add the two vectors like that. Pretty straightforward. Am I doing something wrong? I am doing something wrong. I said gravity. We don't give it a gravity. We give it an acceleration. There is no gravity yet. Acceleration. If I spell stuff right. Come on. There we go. So now we change the velocity, but okay, yeah, we're not moving, right? Because we also have to change the position. So we just say position dot add, and we're gonna add on our velocity. So this dot velocity. Just like that, and now we should be animated. There we go. We fly right off the screen. That was going a little bit fast. We're gonna make this a little bit smaller. Let's try like 0.25. Does that make it go slower? There we go. Maybe make it a little bit smaller. We'll say 1.5. Oops. Yeah, I think that's pretty good. Now, one thing is when we get to the top of the screen, we just kind of keep flying and we just kind of draw off of the canvas. So maybe when we get to the top of the screen, we want to reset our position. And so we have to do two things. One, we have to figure out when we get to the top of the screen, and then we have to figure out when to reset our, and then we also have to figure out how to reset our position. So maybe instead of making a function just to check to see if we get to the top of the screen, we should make a function to check to see if we're actually if we're visible, if we're in bounds, right? So in bounds should be a function that returns true or false if an object is in bounds. So we're going to do that. We're going to make a function up here, and I'm just going to call it function. It will be in bounds. That will be the name of the function, and it's going to return true or false. And basically, to check if we're in bounds, it should give us like an x component, a y component, a width, and a height. And I'm too lazy to type in width and height, so we'll just use w and h. X and y is our coordinates. So one way to check if we're out of bounds is if our x value is greater, and our coordinate's going to be in the upper left. So if our x value is greater than the width of the canvas, we're out of bounds, right? So we'll just say if let's see, if our x is greater than our canvas dot width, then we want to return in bounds returns false, right? Because we're out of bounds. In bounds is kind of backwards, right? In bound returns false. Else, what we want to do is we want to return true. Okay, pretty straightforward like that. So this right now we can be this way, but we can also be too far to the right, right? I'm sorry, too far to the left. So to check that, we say, okay, if our x position is less than 0, right? But what if we're like halfway off? Because our origin's in the upper left-hand corner of that rectangle, really we want to offset that position. Well, we want to check to see if that position is if our x coordinate plus our width is less than 0, right? To see if we're off the screen. So we're going to do that right here. So we say, so if we're greater than the width, or what else can return false? If our x component plus the width of our object is less than 0, so if you're drawn too far this way, and that will reset it. So now it checks the x component, but we also want to check the y component, right? So we'll also put like an or there, and to check the let me get the screen here so I can point to it. To check the y component, we have two things. This is 0, right, on y. So if our y position is less than 0, we'll be drawing somewhere between here and the width of the object. So if we say if our y position minus the height of our object, so if we take our y coordinate here, I'm sorry, plus, right? If we take our y coordinate here and then we add on the height of our object, we basically get the bottom of our object, and we can say if that bottom of the object is less than 0, right, we're off the screen. So we say or if, and then we just say our y component plus our height is less than 0, right? So for our y component plus our height is less, if the bottom of our screen is somewhere up here, or if the bottom of our rocket is somewhere up here, we return false because we're not in bounds anymore. And then also we have to check if we go too far this way, which will just be if our y component, right, the upper left hand, the top of our rocket, if our y component is greater than the width of the canvas. We don't have to offset by width because we're already in the top, we're drawing to the top, right? So we just say, or if y is greater than the canvas, I said width, I meant height, canvas.height, just like that, return false. And that basically counts if we go too far this way, too far this way, too far this way, or too far that way, and that will check to see if we're in the canvas using just square coordinates and no rotations. Okay, so we have inbounds. Let's go ahead and put it to use down here. So maybe before we draw the rectangle, we should check to see if it's inbounds, and if it isn't inbounds, we should reset the position, and then draw the rectangle, and then if it is already inbounds, we just want to draw the rectangle, right? We don't want to reset the position. So I'm going to write it right in between these two. So we're going to say if, and we're going to say basically the other way around. So we're going to say if inbounds, and it's lowercase b, right? Inbounds, and then this takes in a x and a y, so it would just be position.x and our position.y, and then we also want to take in this dot width, because it takes in how wide we are, and it takes in how tall we are either. So also, so this dot height. So if it's inbound, but really we want to reset the position if it's not inbounds. So to reverse this, we just use the not operator. This just basically flips a boolean, right? So if this returns true, this will flip it to be false, and if this returns false, this not will flip it to true. So it just does the reverse, which we want. So if we do if not in bounds, then we want to reset the position. So we'll say this dot reset, and I haven't made a function to reset the position, so let's go ahead and make one right now, and we'll just say reset is defined as a function, and maybe reset just does all this original code up here. It resets our position, and it resets our velocity to 0. So it just starts this as a not moving object in the bottom of the screen. We don't have to reset our acceleration because this is constant, right? The acceleration doesn't change. So we go ahead and maybe just do that down here in the reset function. And then when we initialize our rocket, we also want to say to initialize it, instead of having to write that code, we can just call this dot reset, and that will reset our position for us. There we go. And when we get to the top of the screen, there we go. It just resets our rocket like that. When we get drawn off the screen, it will reset our position. So that's pretty straightforward. Now we have a rocket that's moving around. Now we want to give it like a really cool smoke trail. So let me check the time. Let's see where we're at here. 26 minutes. Wow, man, this thing goes on. A smoke trail, though, is pretty straightforward. I want to make a smoke trail just... I want to refer to a smoke trail as one object, and then that smoke trail is going to, yeah, okay, so we're going to create a class called SmokeTrail. Okay, and SmokeTrail is going to have a constructor that we're not going to do anything in yet because I don't know what it's going to do yet. And then inside of Rocket, we're maybe going to give it a smoke trail as well. So say this dot smoke trail is equal to a new smoke trail, right? So we'll do that, and then smoke trail is maybe going to take in, yeah, we'll do this in a little bit. Smoke trail is going to have lots of smoke, so let's make another class called smoke, right, which will just be like a particle of smoke. And smoke should also have a constructor, and it should do stuff. And then we want to also have maybe, yeah, we'll have a function in here called animate, which just gets called each time we animate. So when we animate a rocket, we're gonna basically draw our rocket, and then we're also going to want to draw our smoke. And we probably want to draw our rocket over our smoke, right? So we'll draw our smoke first, and that to do that we just say this dot smoke trail dot animate. Okay, just like that. And our smoke trail that will call this function here. And maybe in our smoke trail, we just have lots of we have like an array of smoke particles. So we say like this dot smokes, right? It's an array of smoke particles is equal to an array. And then over in animate, we just iterate over our smoke array, right? So for, and I'm going to refer to that as variable smokes is equal to this dot smokes, just like that. And then we can say for variable x is equal to 0, x is less than smokes dot length, oops, x plus plus. So we just iterate over the smoke trail, and we'll say we're going to take, we're going to make another one called like smoke, which is equal to smokes at position x, and then we're going to say smoke dot animate, and we're going to animate that smoke particle. And so now inside smoke we also need something to animate it, and this is where we're going to draw in the particle of smoke. So now we should probably give it like some things. So like this dot width is equal to we'll make it a square particle, so we actually won't even give it a size. We'll just give it a size, right? This dot size is equal to like 10 pixels is pretty big. We'll do 5 pixels, okay? Half the size, the width of a rocket. And we'll also want to give it a position, right? So this dot position is equal to a new vector. All right, and the smoke particle, we want the smoke particles to come out the bottom of the rocket. So we're going to be creating new smoke particles inside of inside the smoke trail thing, when we animate it, right? Maybe we'll draw like it will add new smoke particles to its array. So and that should have reference to our rocket's position, right? So let's give SmokeTrail is going to take in a rocket, okay, and it's going to set this dot rocket equal to the rocket, okay. And so then instead of creating a new smoke trail and just passing through nothing, we're going to pass through our instance of the rocket. So it will just be this a new smoke trail with this, and then we'll animate, and then maybe our smoke particle takes in an X and a Y position, right, to start out with, and it just sets its position to X and Y, and then each time we animate, right, let's have another. We want to add smoke to the array each time that animate gets called. So maybe we'll have another variable up here, and we'll just call this like smokes per animation, and we'll set that to like 3, and then we'll say we'll keep the smokes array up here, and underneath that we'll say another loop for variable x is equal to 0, x is less than this, dot smokes per animation, x plus plus, right? And then we're going to want to push a new smoke object to an array, and JavaScript lets you do that. You just say smokes dot push, and then what do we want to push to it? We want to give it a new smoke object, and smoke, remember, takes in an x and a y position, right? And to set our new position, we want it to be the bottom of the. We want it to start at the bottom of the rocket, right? So I don't know. Let's start with the. Let's just start with the height, the y component of the smoke. Then, if we want it to be the bottom of a rocket, and our rocket's drawn from the upper left-hand corner, it's just our rocket's position dot. You know, it's our rocket's y position, but then plus the width of the rocket, right? So that's what I'm doing. I'm going to say it's going to be this, and I'm going to refer to rocket as another variable up here. Variable rocket is equal to this dot rocket, just so I don't have to keep dereferencing this. And then now we just say, okay, it's our y component is going to be our rocket dot position dot y, and then it's also going to be plus our rocket dot our height of our rocket, height, right? And then for the x component, we want it to start like maybe in the center of the rocket object. So again, if we just draw it at a rocket's x position, we won't be in the center. We'll be like off to the left of it. So we want to draw it to in the center. We have to add on half of the rocket's width, right? So to do that, we just say it is our rocket dot position dot y or x plus our rocket dot width divided by 2, right? So we add on half our width. That will start the smoke particle right in the center of the rocket's jet like that. That will be its position. And maybe when we animate the smoke particle, we should have a color again. So we'll make a new variable called this dot color, and we'll set the color equal to smoke should be gray or something like that. But let's try like what's a good color here? Well, we can change the color later, but for now we'll just use gray, right? We'll have gray smoke. Maybe that's going to be hard to see in the background. Maybe we want like a cherry red. Here, let's ask Chrome, what color is a good color? If we go to elements and we say color, what colors are supportable? We'll say we want like a dark red. A dark red. That is a valid HTML5 color. So we'll just go ahead and set our color to be equal to dark red. Like we'll have like red smoke, like a burning ember, right? And that will contrast the sign nicely. All right, and then each time we animate, we want to set the context dot fill style equal to this dot color. So we're going to set the color to that red color, and then we also want to say context dot fill rect, and we're going to want to fill a rectangle starting at and I'm going to dereference its position again. Variable position is equal to this dot position, and then we're going to say fill rect at position dot x and position dot y for this dot width, or I'm sorry, it's a square, right? So it's just this dot size and this top size. So that way it will draw like a square smoke particle there. And now, why don't we get anything? We should at least get something. We get that particle there. We get that particle there. Each time we are animating the smoke trail, right? Let's see. We get a bug and we get a bug in the console. We do get no, we don't. No, we don't get a bug in the console. So if we animate the smoke trail, basically we add new smokes to the smokes array, and then we iterate over each one of the smoke particles and animate that particle. The particle gets a position X and Y, and we basically draw to this positions X and Y for a square of this dot size. Let's, instead of drawing to its X and its Y position, let's just draw to something that we know where it is. So maybe we'll say 0, 0, right? We know where the 0, 0 is on the screen. So let's see if we draw 0, 0. Okay, there is a particle up there. It's really dark, but I see it. It's right there in the corner of the screen. So that's working just fine. I think the problem is it's just the rocket's moving too fast, and so I can't see it, and dark red really is dark red. Let's make it like just normal red at first to see if we can actually see what we're drawing here. So let's see, is it, no, we should be able to see like a red trail following it. So why isn't following it? Oh wait, no, that should draw just fine. It should be, oh boy. Oh, I said height 0. That's going to put it at infinity. Okay, there we go. Just height. There we go. Look at that. And now we get something there. That's kind of where we're going at. So we have a smoke trail going, but you can see it's offset to the left, and that's because when I fill this this rectangle, I want to draw it, or its position, right? I gave it for the middle of the rocket, but then I have to offset by our size again. But so I'm going to say, instead of just creating a new position at position X, it will be position X minus this dot size, but plus half of our plus half of our width. So that way it draws in the center of the rocket. And now we have these like smoke particles that are being drawn. Another thing to check too is maybe our smoke trail. It will animate each one of our smokes, right? But it should delete them. It should remove them from the smoke spray. Right now the smoke spray is just getting bigger and bigger. It should delete the particle if it's out of bounds, right? That way we don't keep drawing forever. So inside of our smoke trail, after we create smokes, we should maybe iterate over each one of our smoke particles here, and we can say if, and we'll do the same thing. We'll say if not in bounds, and it will take in a smoke. We'll say smoke dot position dot y and smoke dot position dot. Sorry, I did that backwards. If our XY position and our smoke dot size for smoke dot size. So if we're out of bounds, what we want to do is we want to remove the element. So we're going to say smokes dot, and JavaScript lets you remove an element at index X by using the splice function, and splice will just basically, splice takes in two things. It takes in what element to remove, so we want to remove element X, whichever current element we're iterating over, and it will also takes in how many elements to remove once at that position. So we only want to remove one element, so we just want to remove ourselves. So it's just x.1. And then another thing is too, so we're going to remove an element, so our length is going to decrease by 1, so this will work, but we're going to be jumping because of this. When we get to the bottom of this for loop, we're going to jump right over the next element, right? If I was at index 3 and then I remove index 3, right, the new index 3 is actually our next, is the next index, and this will jump to index 4, which will jump over the new index 3. So really I also have to say, okay, take away from X, so that way it just doesn't skip any smoke arrays. And now when the smoke goes off the screen, we don't keep adding more smoke. It just gets removed from the smoke arrays, just like that. That's great. So now we want to animate the smoke and give that like physics and stuff like that. So maybe we'll give it a kind of like just a random velocity, right? So let me pause the video because I gotta get ready to go to school, but I'll be back in just a little bit. Okay, I'm back. Yeah, sorry it took me more than a day to get back to this video, but I was busy with school and stuff. I rewatched the old video to try to figure out where we were at, and we got to the point where we're right down here removing smoke particles if they're out of bounds. Now I kind of misspoke in the first video. This is great if the particles are moving, but right now the particles aren't moving, so they're still being laid on top of each other. But when they start to move, you know, you can imagine if a smoke particle goes over here out of bounds, it will be deleted. So that's great. So let's start by moving the smoke particle. So inside, what we want to do is we want to give our smoke particles kind of like a random position. And to do that, we use the math library JavaScript, and we use the random function just like that. And random will return a number between 0 and 1. And we'll also kind of create two variables. We make variable for velocity for the x, and right now I'm just going to set that to 0. And then we also have variable velocity for the y, and I'll also set that to 0. We probably should have up here like some limits. So right now I have kind of a size for the smoke particle, but I should maybe say like this dot max velocity, velocity, and we'll say the max velocity of any smoke particle is like 3. I don't know, that sounds like a good number. So that will be our max velocity. So we want to scale this the math.random to our max velocity, and to do that it's very simple, right? We just go ahead and we multiply this, because this would be a number between 0 and 1, right? So if it's 0 times our max velocity, it's 0, and if it's 1 times our max velocity, it's 1, and it's evenly distributed anywhere between there. So what we'll say is this dot max velocity, right? Velocity, just like that. And instead of making this actually, well, here, what I'll do, yeah, that's fine. We'll just leave it like that. Let me pull this down here, though, so that we actually have reference to it down here. Okay, there we go. So great, now we have a Vy and a Vx. We probably want to set our velocity to a vector so that we can add it onto our particle's position, just how we change the rocket's position. So to do that, we just say this dot velocity is equal to a new vector, and the vector will have a size, or will have an x component of Vx, and it will have a y component of Vy. So there we go, we create a velocity, and then up here I have variable position. I probably want to have a variable velocity, right? Velocity is equal to this dot velocity. Just capture it there so I don't have to keep writing this, and we'll just say position dot add, and we'll add on the velocity to it. There we go. And now we should start to see some smoke moving. There we go. And now when the smoke gets off screen, you know, it will be removed, so we don't have this infinite smoke array. Now you can see that this is great, but all the smoke it's kind of even a cool effect, but it's all kind of like falling to the right. And that's because we give it a random x velocity, but like I said, the x velocity is between 0 and 1, so we're going to constantly be adding on to x. If we want it to go this way, what we would have to do is create an x velocity that's negative, right? Negative x velocity. And so for that, I'm going to create a new function, because we can use this later on for like a random size. So right above we have inbounds. Right underneath inbounds, I'll go to make a new function, and I'll just say random sign. Actually, let me just make a function called like signed random. Okay. And signed random will take in a it will take in a minimum, and it will take in a maximum. So we can kind of we can generate a random between these bounds, if you will, and signed random will return a signed number between the minimum and the maximum. Let me think. I'll just say, instead of saying signed random, I'll just make it called random. There we go. But this will be our own random that takes in a minimum and a maximum. And then to generate a signed random, we can just pass through a negative minimum value and a positive maximum value, and we'll generate a sign between the two. To do that, it's a very simple, just one line of code. We just want to return. And what we'll do is we'll say a math dot, yeah, it's a one line. We return math.random, which will give us a value between 1 and 0 and 1. And we want to go ahead and multiply that by whatever our maximum can be. So that will be multiplied by our maximum. And then we also want to do add on the minimum. Does that sound about right? I don't know. Let's see, because this will generate a number between 0 and max, and we will add on the minimum, and it will be evenly scaled between 0 and max. But when we add on our minimum, will that kind of skew it down a little bit? I don't know. Because if this is our maximum, we'll never generate one that's our maximum. Yeah, so there we go. We actually have to subtract our minimum from our maximum. So that way that we generate a number, we weight this properly, and then we'll add on the minimum over here. There we go. That way it adds on the, I think it weights it properly that way, right? Because we can, if like minimum was 0, let's say 1, right, and maximum was 5, right here we generate a number between 1 and 5, and then we would add on our minimum, which would be 6, so we would never actually get to, like, we would go over a maximum, and that's not good. I was thinking in negatives, where if this was like -1, and this was 5, right, if we generate a number between 0 and 5, and then we add on -1, we'll have -4, we'd never hit 5, which would be our true maximum. So this way we'll generate a number between our max and our min, and that's evenly weighted, and then we'll just add on our minimum velocity like that, and that should weight it properly. So now down here, instead of having to do this crazy stuff down here, I went a little bit too far, we have a max velocity, right? Instead of doing this stuff up here, what we'll do is we'll just generate a new vector between, and it will take it, it's a random number. It's a random, probably should spell random right. It's a random between 2 points. We'll say negative velocity. Here, I'm just gonna, and I'm gonna velocity, and I won't actually, I'll do it this way. This dot max velocity, just to store it. I mean, we probably don't need this ever again, but we'll store it just in case we do. Is equal to max velocity. My gosh, I can't spell. Max velocity. Oh my gosh, velocity. Okay, there we go. So we'll generate a number between our negative of our max velocity and our positive of our max velocity. For our x component, and then for our y component, we want to generate a random number between 0, right? Because we don't actually want the smoke particles to go up, right? We only want the smoke particles to go down. So we'll say between 0 and max velocity. That sounds pretty good. Velocity just like that. And now when we look at it, we have kind of a more fair, or we have our smoke particles that how do I say, are given random velocities evenly in both directions instead of just being weighted to the right. Okay, so that's great. That's our smoke for you. Now, one thing about the smoke particles here, it doesn't really remind me too much of smoke. It's more of just like a particle coming out the end of the rocket, right? It's not, when I think of smoke, it starts out like as a heavy cloud, and then over time it kind of like fades and dissipates. Now, to get that kind of illusion, what I want to do is I want to give these smoke particles like a lifetime. So like their lifetime will be how long that they can persist before they actually disappear, right? So right now they disappear when they go out of bounds, which is great. But let's try to make them disappear. Like, see this smoke particle that's lingering on here, right? He's lasting a lot longer than these guys that are just flying off the screen. So these persistent ones, we want to get rid of them. So to give them a lifetime, we'll say when they're born from the rocket, they'll be at age 0, and then when they each time they get animated, their age will increment, and we'll give them a maximum age, right? A lifetime that they can live for. And if they're older than their lifetime, we'll just remove them anyway, even if they're not off the screen. That sounds like a fair way of doing things. So to do that, in each particle down here, I have a size. I'm also going to add a lifetime to them. So I'll say this dot a lifetime, and I'll say each one I want them to last a maximum of we'll say 50 animations. That sounds like a good number. And then each time that we animate, we're also going to go down here and we're going to say this dot lifetime plus plus, right? So we're just going to increment the lifetime each time we animate. And actually, to be fair, we should probably do this at the bottom here, just so it's out of the way, so we can still change our position and everything down here. So in our smoke trail now, when we animate them, we say if in bounds, right? We basically remove them. We'll add another check too. And it doesn't really matter what order they are because they're random velocities, right? Some of them will probably be out of bounds before their lifetime. Some of them will probably be in bounds before lifetime. Just from looking at this, it looks like a lot of them actually get out of bounds before their lifetime expires. So I'm going to put the lifetime after the inbound check. So it will just be down here. So we'll say if they're not in bounds, or if smoke dot, we'll say it's age is greater than or equal to its smoke dot lifetime. Oops. We'll remove it, and this is after we animate them, right? So, or no, this is before we animate them. I guess this is fair, right? Because if they have a lifetime of 0, we don't even want to animate them once because they're going to be dead when they're born. So I guess this is a more logical flow of a more logical flow. So we'll leave it that way, and I'll maybe add a little bit of spacing there to make it more readable. And so now we need to have an age, so we can see this time I said lifetime plus plus, I went age plus plus. So we have a lifetime of 50, but then we also want an age to be equal to 0 when they first start, right? This dot age is equal to 0, so they start out at age 0. Maybe I'll also kind of break this like this so that we can read it. So now they have an age and a lifetime. You can see now when they hit their lifetime, right, when their age hits their lifetime, we remove them. So you can see now they're all kind of being removed right here when they're all old enough. So what we should do though is this kind of doesn't look like real smoke, right? Real smoke, some of the particles last longer than the other ones. So we want to kind of give them again like a random lifetime. So maybe instead of giving them all the same default lifetime, we'll just give them a max lifetime, right? A max lifetime of, let's say, and we'll make it a little bit bigger than 50. 50 looked a little bit small. We'll make it like 150, okay? 3 times as big. So that's their max lifetime. And then to give them an actual lifetime, we probably want to say this dot lifetime. Oops, did I do capital? I don't think so. Did I don't, maybe I did. Shoot, I'm starting to forget. Where do we said it was lowercase. Okay, so we'll say this dot lifetime is equal to, and we'll use that random function again. That's why we pulled it out to a function so that we can use it for all these different things. and we'll give it a number between 0, right, and max lifetime. Max lifetime. Okay, and again, I'll make this a variable instead of part of the component, part of the rocket. And just to store it, we'll say this dot max lifetime, just so we have access to it later if we ever need it. Lifetime is equal to max lifetime. Now, there we go. So now they're given kind of a random lifetime, you can see, and they'll start to disappear at different moments, right? They're not all living for the same amount of time. They're given kind of that random lifetime, which looks pretty good. So that seems pretty good. Another thing that we want to do probably is, so they are all kind of living for a random amount of time now and not really persisting. But they're staying the same size. So we, like I said, smoke kind of thins as it ages. So what we want to do is we want to make the smoke smaller as it gets older. That's probably a good way to do it. So down here, when we animate this, before we, we adjust its position, that's fine. We can do that right there. And then underneath that, we probably want to change its size, right? So right now we're just drawing to its size. So maybe we want to decrement its size if it's old, or if it's old enough, or we want to decrement its size in relationship to its age. So to do that, what we probably want to do is, if we take its lifetime, or if we take its age, right, and we divide it by its lifetime, we get kind of a percentage of where it's at in its phase. Right, like this would be a number between, this is a normalized value. It will be between 0 and 1, because it will never, the age starts out at 0, and it will never live past its lifetime, because the SmokeTrail will remove it. So this is a value between 0 and 1. And what we want to do is we want to change its size based off that value, right? So for that, what we want to do is multiply. Okay, so this will be a value between 0 and 1. What I want to do is I want to flip this, right? So right now, if I multiply this by the size, if it's 0, well, here you can see what we'll get. We'll say variable size is equal to this dot size multiplied by this, and if I draw it at this size, we get kind of the inverse effect of what we actually want, right? They start out to be very small particles, and then as they get close to their end of their life, they grow, because no, that one got really big. I guess we had maybe I don't know what happened there. Maybe it was just two next to each other or something like that. So you can see, this is kind of a cool effect. It looks almost like fireworky or something like that. But as they get really old, they grow quite a bit. Oh, if lifetime is 0, right, you get infinity. So instead of saying a lifetime of 0, we should say lifetime of 1, right? So they can only ever live for 1. That way, when you divide by 0, you don't get an infinitely large smoke trail, so we don't get that flash there. That's what that was, right? So we can only live to, 1 dead lifetime. That's fair enough, right? You'll at least be animated once before you disappear. Okay. So when we animate, we want to flip that. So this is the smoke trail, isn't it? Yeah, smoke trail. We want the smoke. So what we want to do, instead of multiplying its size by this age divided by lifetime, we want to multiply it by 1, take away that, because this is a value between 0 and 1, and this will kind of flip it for us. So we definitely want parentheses, because order of operations, right? So that way they'll start out at size, and then as they get older, they'll shrink down, and now you can see it kind of looks like they're fading as they get older, and I think that's a really good effect right there. That looks pretty good and pretty convincing of more of a more natural smoke effect. Actually, it looks almost a little bit like snow, but that's okay. So I think that's we're on a roll here. and this is kind of the core of the rocket model. There's a couple of other things that we can add to this to make it look more convincing. So we'll do that. One is I have the size that I animate here. I guess we can do it this way. We can recalculate its size rather than storing its actual size in its size. To be a little bit more correct, though, I guess we should technically, like, instead of having size equal to 5, we should make this like a max size equal to 5. And then down here where we animate, we say this dot max size, and we never change the maximum size of an object. We just leave it at 5, and we say animate there. And then what we can do too is we can say this dot size is equal to size. Now we don't really even need to store the size variable, so I won't even do that. That seems kind of redundant there. Kind of like storing these other, like, max velocity, right? We only use them once to calculate, but we'll keep them there. Size gets recalculated each time, so we're not even going to bother to store it. Why isn't this working, though? This dot max size equals to 5, and we have variable size equals this dot max size minus this dot age over lifetime. Oh, because I say this dot size, this should be maximum size, right? There we go. Okay, that's good. So another thing that we can do is maybe make their maximum size a little bit random to make it a little convincing. And not every smoke particle starts out to be the same size. Maybe they start out to be a little bit bigger, a little bit smaller. And we generate a random number between the two. To do that, that's okay. What we can do is say this dot max size equals to a random number between, maybe we'll say the maximum size will have a minimum size of 3, and we'll have a maximum of 10. All right, and now they're each given kind of like different size smokes to start out with. That looks pretty good. That's a little bit too exaggerated, though. I'd say maybe we should make this like 6. Maybe that's a little bit better. Now they're kind of just another little bit of random elements to them to kind of make them look more convincing. Another thing we can do is give them gravity, right? Right now they just have like right now it's like 0G rocket, but if this rocket was launching on Earth, right, these particles would also be weighed down by gravity. So to do that, that's pretty easy. We just say down here where we create a position vector, we could also create like a gravity vector. So we can say this dot gravity is equal to a new vector. Vector, and we'll say it's it doesn't affect the x component at all, right? Because gravity's only pulls down, and it affects the y component in a positive manner, right? Because we're pulling down, and our coordinate systems go down this way. And we'll just say gravity is a constant, and we'll say it's positive 0.02 or 0.15. That sounds like a reasonable value. And then down here, each time when we animate the smoke particle, before we add the velocity to the position, what we'll do is we'll velocity dot add, and we'll add. Never mind. We'll add the gravity to the velocity, right? Because acceleration is just kind of it's a velocity for your velocity. Okay, that's pretty good. It's a little bit, I think, a little bit too much of an effect, though. You can see they kind of really start to. It looks more of like water now than a rocket. So maybe we'll make this a little bit smaller, like 0.15. Just a little bit of gravity there. You can kind of see they'll start to be pulled down. The older particles will be, but not enough to kind of make it look like water. It still looks like they've got a little bit of like they're being blown in the wind. Oh, that's another good one. We can give them kind of a wind, right? So we give them a gravity. We can give them like a wind effect, right? So wind. To make them look like they're being blown around in the wind, well, to be really cheap, we can kind of do like a size things where we recompute it each time, and we just change its velocity. So we add the gravity to the velocity, that's constant, but we can also add like to the velocity dot add, and we can add a new like wind vector. Actually, we don't even have to do, well, let's have wind like only be blowing left and right, so it only affects the x component of the velocity, and we'll just add to that a random number between we'll say negative this dot wind speed and positive this dot wind speed, right? Wind speed, okay? And we should probably say camel type that, and then we'll create a variable up here for wind speed. We do age and lifetime, size, and gravity. We should probably do it maybe this down. It seems appropriate to place it in here. This dot wind speed is equal to, well, it could be we can be exaggerate at first just to see the effect that we'll do. You can see kind of makes the x and the y components like really random. That's a little bit exaggerate, or a little bit too exaggerated to look realistic. So maybe we'll make it like something really small, like 1. Even that might be a little bit big. Yeah, even that's a little bit exaggerated. So we'll do like 0.015, just like gravity maybe. That's a little bit under exaggerated. Maybe we want to make it a little bit bigger. We'll say like 0.1. You can kind of see it. Maybe 0.25. Maybe that's a little bit better. Yeah, I can see they're kind of giving kind of like this blowing in the wind effect, right? Where there's just kind of a little bit of wind that's just kind of pushing them around. It's not that great of it. Oh, that one kind of shut out, right? He got pretty good. It's not too great of an effect because the winds can cancel out over each way, so that's good. But maybe like if you wanted to make this look more realistic, we could add on like like kind of like wind currents, right? We can have a current of wind so that they all kind of go in a general direction. But I mean, just for starting out, this rocket seems pretty good. The only difference I think between my rocket and this rocket, I mean, I kind of like this one better. It's got a little bit of a better, the way that it's set up is a little bit better. But one of the big differences, I just have a lot more smoke particles. So I say smokes per animation is 3. We can, just add on a lot more smoke effects, like go to 10, right? And now there's a lot more smoke that comes out the end of the rocket, and that gets animated better. So there's just more particles that way. Maybe the wind is a little bit too exaggerated. So I'll shrink the wind down a little bit, and maybe we'll just do like 0.2. Maybe that's better. 0.15 was a little bit small. We'll do 0.18. That's yeah, that looks pretty good. And then what we can do is maybe add the velocity, the velocity of the smoke particles coming out. We can increase that. So the max velocity we say is 3. Maybe we make it like 5 to give it so that the particles are more like shooting out of the rocket. Yeah, we get a little bit, gravity's I think a bit too weak now if we have that velocity, so maybe we'll increase gravity. I don't know, something doesn't look too great to me. We can do 0 like 5. Maybe that's better. Yeah, that's better. You can see this is like kind of the start of the rocket engine, and you can mess around with this and change all the variables, make it look different color. Maybe so right now we change the color. We change the size based off the lifetime of the rocket. You can also change the color. So maybe when the smoke just leaves the rocket, it starts out at a very bright like yellow color, and then as it gets older, it turns to more of a dark red color. And you can do that by messing around with like the HSL value or the RGB. I would do HSL if you were going to do like a color effect like that, because then you can change the lightness value and keep the hue and saturation the same. That way you could just change the lightness value of it. But yeah, that's kind of like the rocket engine in a nutshell. That's not too long to program. It took me longer to explain than I thought it would take. And I'm sorry for the long delay between each video because I had school. But yeah, that's the rocket. And feel free to take this and use this code however you want. Definitely feel free to kind of modify this code and make it your own. You know, this is I want you to use this as a learning experience. But for a rocket, I think that's pretty good. Here, maybe we'll go out with a bang. Let's see how much smoke particles. Maybe we'll just go with a lot of smoke. Here we go. There's 100 smoke particles. It does so. Maybe that's a bit excessive. That looks like it's kind of more smoke than rocket. maybe 50, right? I don't know. I kind of like it with less smoke. I like it with 25 looks okay. 25's okay. Maybe we'll make the smoke a little bit bigger. Where's the smoke size? This dot max velocity. This dot max size. 3 to 6. We'll make it. Maybe we'll make the minimum size. We'll make the maximum size like 8, and we'll make the minimum size 4 maybe, or maybe we'll just go. Yeah, that kind of. Well, maybe that 8's a bit excessive. 7. 6. Yeah, that looks pretty good. All right. But anyway, yeah. So take this and run with it, and definitely do something. One thing that I'm kind of seeing is that the smoke particles are clumping together on their. Are they? Maybe a little bit on their Y components because we only set their velocity once, and they're both accelerating downwards at the same time. So they do have separate Y velocities, but it's not very. They don't get varied ever again. Maybe you want to have the wind affect their Y velocities as well. Maybe you want to add some air resistance, some cool stuff like that. So hope you enjoyed this and learned something from it. And it's it's not that long. This was 144 lines of code, and you got big results from it, right? All right, thanks for watching. Bye.